This is the first page. This is an experiment in which half of the people were given a strategy to take a test. The other half were not given the strategy, and each person received an exam score. I want you to tell me what the name of the independent variable is, what the names of the levels are, and what the name of the dependent variable is, and also tell me what type of design it is. I also want you to calculate the mean of the 5 exam scores of group 1 and the mean of the 5 exam scores of group 2. This is the second page. This is supposed to be the same experiment, except this time each person was asked how many hours they studied for the exam, and the participants were matched based on how much studying they did. These two people are pair 1, these two people are pair 2, these two people are pair 3, all the way down. What I need you to do right here is assign one person from each pair to the aware group and one person from each pair to the not aware group. So on these two lines, write aware on one of them and not aware on the other one. For these two lines right here, write aware on one of them and not aware on the other one. And since it's supposed to be random assignment, don't do it the same way each time. So don't do aware, not aware, aware, not aware, all the way down. Switch the order around for some of the pairs. So after you finish all of these lines, and everyone has been assigned to a group, make up an exam score for each of the 10 participants and write those 10 exam scores in here. For each person, just try to think of what their exam score might be based on how much studying they did and whether or not they were aware of the strategy. Once you fill in all 10 exam scores, I need you to create a scatter plot down here for studying and for the dependent variable of exam score. And you'll have 10 dots in your scatter plot because for person 1, they studied 1 hour and they'll have an exam score. You'll use those 2 numbers to make a dot for person 1. Person 2 studied 1 hour and they have an exam score. You'll use those 2 numbers to make a dot for person 2, and you'll put all 10 dots in here. Next, you'll fill in these results right here. You'll calculate the mean studying of the aware group, which means you'll just add their 5 numbers, which will come from here, and divide the total by 5. Then you'll calculate the mean studying of the not aware group. You'll just take their 5 numbers from this studying column and add those 5 numbers and divide by 5 to get these 2 means. Next, you'll calculate the mean exam score of the aware group and the mean exam score of the not aware group. Those numbers will come from here. You'll take the 5 exam scores from the aware group, add and divide by 5 to get this mean, and take the 5 exam scores from the not aware group, add those 5 and divide by 5 to get this mean right here. Once you've calculated all of those, well, you'll tell me if it was a good matching variable. If there's a strong correlation in this scatter plot between the dependent variable and the matching variable, then it was a good matching variable, and the answer would be yes. If it's a weak correlation, the answer is no. It doesn't matter if the correlation is positive or negative, it just has to be a strong correlation. Was the matching done properly? You'll have to look at these 2 numbers inside of each matched pair and see if they're similar to each other. If each person and the person's matched partner are really similar in studying, then the matching was done properly. But if the 2 people inside each matched pair are highly different from each other, the matching was not done properly. And this last question says, was the matching effective? That depends on 2 things. If there's a strong correlation in this scatter plot, and these 2 means of studying are highly equal to each other, then the matching was effective. The matching did its job. And all of these questions about what type of design it is, and these fill-in-the-blank questions you've already done those earlier. Here's another page. This is an example in which each person is tested in both conditions. You'll start with these blanks over here. You'll assign 5 people to AB and 5 people to BA. and you can pick which 5 go to each order. So let's say I've assigned person 1 to AB and person 2 to BA. For each person that I assigned to AB, I'll put time 1 here, because they're getting condition A at time 1, and time 2 over here, because they're getting condition B at time 2. For each person I assigned to BA, this will be time 2, and this will be time 1, because they're getting condition B first, and then condition B, and then condition A second. For each person, after you've done all of this, I want you to add 20 to each time 2 score because of practice. So for each time 1 score, just leave it the same number I have in here. And for each time 2 score, add 20. So this would stay 80, but this would go up to 75. This is time 2. This would go up to 90, but this would stay the same because it's at time 1. So it stays 71. So you'll have 10 numbers in here, 10 numbers in here. Those 20 numbers will be our actual data set. And half of the scores are affected by practice. Well, all of the time 2 scores are affected by practice. I want you to tell me what type of design it is. Answer this question. For the results, these are hypothetical results with no practice, no effective practice. So what I want you to do is calculate the mean of the 10 numbers in this red box and put that mean here for the aware condition. Calculate the mean of these 10 numbers in the red box and put that mean over here for not aware. For actual results, I want you to take the 10 numbers that you wrote out under aware, calculate the mean of those 10 numbers, and put that here. For this one, calculate the mean of these 10 numbers that you wrote out for the not aware column. After you calculate the mean of these 10 numbers, put that under here for the actual mean of the not aware condition. So up here, we have the mean of the left red box and the mean of the right red box. That's up here. Down here we have the mean of the 10 numbers you wrote out in the left column. Here you have the mean of the 10 numbers that you wrote out in the right column right here. What type of design? Well, you already answered that. If the difference between these two means and the difference between these two means is the same difference, then neither condition benefited for practice. So like, if this is 75 and 55, that's 20 apart. If this is 80 and 60, that's also 20 apart, which would mean that the difference is the same. The difference is 20 and 20. So in that case, neither condition benefited from practice, or neither condition benefited more from practice. But if the difference changes, if this difference up here is either larger or smaller than this difference down here, then one condition was affected by practice. Over here, I want you to put the mean of all scores at time 1. There's 10 of them, 5 in here and 5 from here. Add all 10 of them and divide by 10 to get this mean. Calculate the mean of all time 2 scores. 5 of them are from here, 5 from here. Add all 10 of them and divide by 10 to get the time 2 mean. Subtract the time 1 mean by the time 2 mean, and your answer will be the practice effect right here. That's the number that goes there. So I told you that the mean of all 10 numbers in this red box goes here, and the mean of all 10 numbers in this red box goes here. Those two means go here. What these numbers in the red box are supposed to be is what all 20 scores would have been if they all came at time 1 and there was no practice. The other numbers that you wrote out are the actual data set. So the mean of these 10 numbers that you wrote out goes here under actual results. The mean of the 10 numbers you wrote out here goes under here for actual results. Here's another page. what I want you to do starting out is fill in these 10 lines. For each one, either put AB or BA. If the person was assigned to the AB order, put AB. If they were assigned to the BA order, put BA. Then calculate the mean of the aware condition and the mean of the not aware condition and put these two means in here. Then move on to this page. Here I want you to separate out those numbers from the last page and put all 5 exam scores from the aware condition that came at time 1 under here. Put all 5 exam scores from the not aware condition at time 2 under here. Calculate the mean of these 5 numbers. Calculate the mean of these 5 numbers and put the two means right there. So add these and divide by 5. Add these and divide by 5. Subtract this mean by this mean to get an answer, and then put that answer as the difference. Down here, put the 5 exam scores that came at time 1 under here for the not aware condition. Put the 5 exam scores put the 5 exam scores from the aware condition at from time 2 under here, and then calculate the mean of these 5 numbers, put it here. Calculate the mean of these 5 numbers, put it here. Then, just like before, subtract this mean by this mean and get an answer for difference. So all numbers here. So this says time 1 at the very top. These 4 numbers and these 4 numbers, all 8 of them are time 1. These 4 numbers and then these 4 numbers, all 8 of them are from time 2. You have to look to see whether these two differences came out to the same number or different numbers. If the two differences come out the same, there's no asymmetrical transfer. If they come out to different numbers, the results were affected by asymmetrical transfer. In that case, it would mean that the difference between the aware mean and the not aware mean depends on the order of the two conditions. That would be asymmetrical transfer, where the difference between the means of the two conditions depends on which order they're received. Here I have some multiple choice questions. If an equal number of people were assigned to each order, then it was properly counterbalanced. Here you'll give a yes/no answer for the asymmetrical transfer, and here you'll tell me if the asymmetrical transfer made the difference between the means of the two conditions between aware and not aware smaller or larger. Next, I'll have you do some calculations with a factorial design data set with 2 independent variables. I need you to get the 4 cell means. To get each cell mean, just add the 2 numbers in the cell and divide the total by 2. I also need you to get the marginal means. To get them, so you have column marginal means and row marginal means. To get this mean right here, add the 4 numbers in column 1 and divide by 4. To get this marginal mean, add the 4 numbers in column 2 and divide the total by 4. To get this marginal mean for row 1, add the 4 numbers in row 1 and divide by 4. To get the marginal mean for row 2, add the 4 numbers in row 2 and divide by 4. So you have row means and column means. If the 2 column means are different, there's a main effect of this first independent variable. If the 2 row means right here are different, there's a main effect of this other independent variable. If the difference between these 2 cell means is not the same as the difference between these 2 cell means, there's an interaction. In other words, if in a graph, if the line connecting these 2 cell means up here is not parallel to the line connecting these 2 cell means, then there's an interaction. An interaction is when the cell means are not parallel in a graph. If the line connecting these 2 cell means is parallel to the line connecting these 2 cell means, then there is no interaction. I'll have you create a graph for main effects and the interaction. Here you'll just make a dot for the mean of column 1, a dot for the mean of column 2, and connect them. Here you make a dot for the mean of row 1, a dot for the mean of row 2, and connect them. Here you have to put either these two levels or these two levels on the x-axis and make two separate lines. So let's say you decide to put aware and not aware down here. Up here above aware, you would have a 30, a dot for the 30-minute condition mean, and a dot for the 60-minute condition mean. So 2 dots. Above not aware, you'll have a dot for the 30-minute condition and a dot for the 60-minute condition. Going from left to right, you'll connect the two 30-minute means, and you'll have another line connecting the two 60-minute means. And then you'll look to see if the two lines are parallel. Here, I'll have you look at this diagram and tell me what type of factorial design it is, one of these three. Here's another diagram. You'll tell me what type of factorial design it is. You'll tell me which participant was assigned to each of these 4 orders. So if this was person 1, you'll put person 1 right here. If this was person 2, you'll put person 2 right here. And then you'll also answer these other fill-in-the-blank and multiple choice questions. Here's one more diagram. You'll tell me what type of factorial design it is, which 4 people were assigned to AB, which 4 people were assigned to AB. So if this was person 1, 3, if this was person 1, 2, 7, and 8, you'll put that here. If this is person 2, 4, 6, 7, you'll put those in here. And then you'll also answer these other questions down here.